Hello students, welcome back. Let us start with a new chapter, that's chapter 9 of your textbooks, which is areas of parallelograms and triangles. Let's take a look at the topics to be covered throughout the chapter. We will start with the introduction like we have done for the remaining chapters so far. Then the next topics to be followed are figures on the same base and between the same parallels, parallelograms on the same base and between the same parallels, triangles on the same base and between the same parallels, and summary. So if you notice point numbers 2, 3 and 4, you have something in common, that is same base and between the same parallels. So what is differing is that the first section we are going to look at figures and parallelograms and then triangles on the same base and between the same parallels. The topics, subtopics for introduction are what is area, examples, units for area, area versus surface area, area of congruent figures, congruency of figures having equal area, area of irregular shapes, and why are we exactly studying about area? Because this chapter is based upon areas of parallelograms and triangles. So the first thing is what is area, right? So let's say I have a circle out here. If I give you a circle and I'll tell you what is the area, mark the area for me. Don't find the area, but mark the area for me. Obviously, you're going to mark this entire section inside, right? All this space out here is your area. Similarly, if I give you any other shape, let's say a rectangle, what is your area going to be? It is the space within this box, right? So when I'm telling you to find areas, or for example for these two figures, you are marking only what is there within the boundaries, right? Are you marking anything outside here? Are you extending your lines like this? No, you're not. You're keeping it within the boundary. So the most simple definition for area is that it is the space that lies within a certain defined boundary. So let's write this down. It's the space within a defined boundary, right? Now examples are not these examples. This is a circle and rectangle. We know exactly now what area is, but just let me grab the duster. Let's take a look at the formulas for areas for different figures. We know that for a circle, so let's say I have area of and formula. We have area of triangle, then parallelogram, rectangle, square, circle, right? We are aware of the formulas for these. What is area of triangle? You have half into base into height, correct? So if this is your triangle out here and this is the base and height is the perpendicular distance. So this is the base and this is the height. Let me draw a larger figure. So this is the height and this is the base. So area of triangle is half into base into height. Similarly, we have area of parallelogram. We know that it is base into height. We know that the area of a rectangle is length into breadth. The area of square is side square. Area of circle is pi r square. So how exactly formulas are calculated for area? I will show it to you with the help of a rectangle. So let's say I have a rectangle that is, let's say 10, the length is 10 and the breadth is 5, let's say 3. So obviously using the formula you can say the area of this rectangle is 10 into 3, which is 30. But how is it calculated? How is the formula derived? I'll divide this length into 10 equal parts. So 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9 and let's say 10. So it is divided into 10 equal blocks, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Similarly, I am going to divide this breadth into 3 equal parts because my breadth is 3. So 3 equal parts. This is 1, this is 2 and 3. So you can see 3 rows and 10 columns. So if you see how many boxes do we have, if you calculate, you have 10 boxes in each row. 10 boxes in the first row, 10 boxes in the second row and 10 boxes in the third row. So how many boxes in total? You have 30 boxes. So 10 into one row, 10 into the second row, 10 into the third row. So 10 is getting multiplied 3 times because that is the breadth. Similarly, if you would have counted it this way, it would have been 3 into 3, 3, 3, 3, 3, 3, 3, 3, 3 and 3. So 3 10 times, see 3, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So 3 into 10 is 30, right. So this is the simplest way area is calculated and I have showed you that for a rectangle. Now what is the unit for area? Now let's take an example of your rectangle itself. Let's say your rectangle is 10 centimeters long and 3 centimeters in breadth. What is area? Area is length into breadth, which is 10 centimeters into 3 centimeters. So I am going to multiply the numbers first, that is 10 into 3, which is 30, and centimeter into centimeter is the same as A into A. A into A we know is A square. So centimeter into centimeter is going to be centimeter square. So always remember that the unit for area will always be unit square, or you can even write it as square centimeters. So it would always be unit square or square units. By units I mean units of measurement. They could be centimeters, they could be meters, kilometers, yards, miles and so on. So your area is always, the answer will always be a numeric value appended with unit square or square units. In our case for this rectangle it is 30 centimeters square or 30 square centimeters. So our unit here is centimeters, right. Now a very important differentiation. What is the difference between area and surface area? So if you see this board, it is 2-dimensional. Why? Because let's say I'm just collapsing this board over here into a small board just to show it to you. What does it have? It has a length and it has a breadth. Even this is the breadth and this is the length, right? So there are 2 dimensions to it. Let's say I extend these axes. So you must have seen your graph sheets. What are these axes known as? This is the x-axis and this is the y-axis. So your areas are only for 2-dimensional objects. So 2-dimensional objects are the best example I can give you is a paper. Okay, so it could be a rectangle, it could be a square, it could be a rectangle, it could be a triangle, it could be a circle. Everything that you can see crystal clear with your eyes. There is nothing at the back side of this. So this is a 2-dimensional object. Now what is a 3-dimensional object? Let's take a look at this box for example. How many faces does it have? It has 1, 2, 3, 4, 5 and another face 6. But when I place this box in front of you, what do you see? You only see the face. Are you able to see the top or the bottom part or the side parts or the back part? No. But it does not mean that it does not exist, right? So the best example for a 3-dimensional object I can show you is a cube, right? So let's say this is a carton that is kept in front of you. You will only be able to see this part out here. But there are other parts to it. There are 5 other parts that you are not able to see. So now this cube, it lies on a 3-dimensional axis. So which are my axes out here? This is, let's say, O, right? Let me erase it and write it more clear. This is O, which is the origin. Here also we have the origin. This is going to be your y-axis, this is going to be your x-axis, and this is going to be your z-axis. In reality, let's take a look at this. You are able to see the x-axis, y-axis, and the z-axis is behind. But for simplicity, this is how your three-dimensional coordinate system is represented. You need not know about these coordinate systems for now. If you plan to take up physics or any or higher maths, then you will come across these figures. I am not quite sure that you are going to learn it in the 9th grade or even in the 10th grade. So, did you get the difference between area versus surface area? So, for area is calculated for two-dimensional objects only. Two-dimensional is nothing but 2D, whereas surface area is calculated for three-dimensional or 3D objects, right? So, obviously, there is going to be a difference in the areas of a sphere and a circle. For a circle, it is two-dimensional. We know that area of a circle is pi r square. How about area of a sphere? Sphere, the best example I can give you is the globe, if you still our earth in fact, or you can even consider a small marble or a ball, right? So, it is a three-dimensional object. So, this, let's say this is a sphere. See, even for a sphere, you will only be able to see the front part, right? You won't be able to see the back part. So, the area of sphere is 4 pi r square. Similarly, if you have a rectangle, then the area is length into breadth. So, let's say I have a rectangular cuboid. The best example I can give you is a carton. What is the surface area? Obviously, the surface area for this is going to be 2 into length into breadth plus breadth into height, that is BH, plus length into height. So, how did I get these? Now, if you notice this box itself, let's say this is the length, this is the breadth out here, and this is the height. So, if you see the first surface, you have two surfaces similar, right? So, this would be what? Length into height. So, 2 times length into height. So, 2 times LH, right? For the front face and the back face 2 times. Plus, now if you see the walls, it has breadth and height. So, 2 breadth into height, then finally you have length into height. See. Sorry, length into breadth. See, this is the breadth and this is the length. So, 2 into LB. So, if you take out 2 common, you get 2 into LB plus BH plus LH. This is also something that you don't have, but just for explanation purpose, so that you get a clearer picture of what is the difference between area and surface area. So, now let's jump on to a new topic, area of congruent figures. Let's say I have 2 triangles ABC and triangle PQR. Let's say the 2 triangles are congruent to each other by the side angle side test of congruence. See, I have marked 1 dash for equality of sides AB and PQ, double dash for AC and PR, and this angle for angle A and angle P. Now, triangle ABC and triangle PQR are congruent to each other by the side angle side or SAS test of congruence. So, let's say if I take my triangle PQR and I place it on top of ABC, it will completely superimpose ABC in such a way that placing PQR on ABC, my triangle, so if I am moving this triangle on this triangle, that is PQR on ABC, it will completely superimpose my triangle ABC like this. So, you won't be able to see that triangle ABC is actually present in the background. So, obviously, now the length, breadth, height, everything of these 2 triangles, let us shift our triangle back, PQR back to its place. So, I have my triangle ABC and PQR back. So, now obviously the length, breadth, height, everything of these triangles, because once you prove the triangles congruent, you can prove that all the sides are equal by the side angle, by the corresponding pair of congruent triangles property, right. Therefore, the area of triangle ABC is going to be equal to the area of triangle PQR. Long story short, area of congruent figures are always equal, right? So if the area of my triangle ABC is 30 units square, then area of PQR has to be equal to 30 units square because both the triangles are congruent. But can we say the same for the converse? That is, if I have two figures having same area, if I have two figures that have the same area, can I say that the two figures are congruent to each other or not? Let's see. The best we can do is, I can do is give you examples. You will learn more through example instead of theoretical knowledge. So again, I am giving you an example. Let's say I have a rectangle whose length is 4 units and breadth is, let's say, 1 unit. And I have a square whose side is how much? 2 units. What is my area of rectangle? My area of rectangle is length into breadth. So this is going to be 4 into 1, which is going to be equal to 4 units square. Correct? How about my area of square? We know that area of square is equal to side square, which is 2 square, which is equal to 4 units square. So now areas of both these figures, that is my rectangle and square, are equal. So can I say that my rectangle is congruent to my square? Let's see. If you try to place this square on the rectangle, will it completely overlap with the edges of my rectangle and completely hide my rectangle? No. Similarly, my rectangle is not, it will hide the square, right? Because see, the edges are small, but it is not completely superimposing. That is, the edges are not going to overlap with each other. So what can you say about congruency? Okay, I have written this over here. Congruency of figures having same or equal area. The two figures may or may not be congruent. May not be congruent. So why do I say they may be congruent or they may not be congruent? I showed it to you for may not be congruent. How about they may be congruent? So if I have, instead of this rectangle, I have another square itself of side 2 units, then obviously the area is going to be 2 square, which is 4, and also see, each side is 2. Even for this square, each side is 2. So my two figures are congruent to each other. So congruency of figures having same area, if two figures have the same area, they may be congruent or they may not be congruent, right? Now let's take a look at area of irregular shapes. Irregular shapes is when you have a combination of various geometrical figures combined to give you one entire figure. In this case, how is the calculation of area possible? So let's say I have been given a drawing paper. So let's say this is a drawing paper and I've been asked to draw a house using geometrical figures. So what I do is I draw a square, then I draw a triangle on top to represent the roof, then I draw a trapezium at the base for my ladders. So I'm just drawing the edge of these ladders, that is in the form of a trapezium, and just for fun I draw a chimney which is circular in shape. So do you think it is possible to calculate the area of this figure? Yes, it is possible. How would I do that? Let's mark your different areas, your different geometrical figures as 1, 2, 3 and 4. So area of this entire house will be what? It would be area of 1 plus area of 2 plus area of 3. So what is 1, 2, 3 and 4 plus area of 4? These are my different geometrical figures in the house. So it would be area of this circle plus area of this triangle plus area of this square plus area of this trapezium. When you add these areas, let's say the area of my circle is 3, the area of my triangle is 7, the area of my square is 16 and the area of my trapezium is 4. How much would this be? 20 and 30. So area of my house, this entire house is 30 unit square. Okay. So you will come across questions like these wherein an irregular shape would have been given to you and the dimensions would have been given for the different figures. You will have to club all the answers for the different figures and then find the total or aggregate area of the entire figure. So I'll say this is the sum of areas of each small unit present in the figure. So this was all about the introduction of area. So let us now we have finally arrived to the question, why study about areas? So why do you think it is important to study about areas? I believe that if I need to divide up my property, usually people face a lot of problems when they have to distribute property. So let's say, I'll give you a real life example that happened to me. I have two other siblings, one elder sister and younger brother. So now what used to happen is, as kids we used to play on our bed, and my sister said that okay, let's play a house and I will distribute this bed amongst the three of us into 3 equal parts. So we said okay. Now I think my bed was about 10 feet long. So what she did is, she first divided into 2 equal halves and she took this entire equal half, which was 5 feet. I realized that there's something wrong. So what I did is, I further took 4 feet over here and gave my brother just 1 foot. So what happened is, my brother and I, we were not really aware of how to calculate area and then divide the area. So my sister was able to cheat us. Either of us, we would have been aware, the area would have been distributed equally for our bed. So this was just a very tiny example when it came to siblings. But let's say you got a lot of property in future and you want to distribute it amongst your siblings or your relatives, then you should have an idea of how to calculate area. Only then will you be able to divide it. Let's say even if you've got property and you grow old and you want to distribute it amongst your kids, to make sure that you're being just to all of your kids, or maybe if you have just 1 kid, then you're very lucky, but if you have 2 kids or 3 kids, then you should probably have an idea about area, because that would, if you don't know area back then it would be a big problem, right? So this was one example. Now let's say you've got 4 walls in your house and you want to paint just one wall in a very different style. Today we have these customized paintings, right? So what the painter is telling you is that this particular wall, I am going to paint it at the rate of, painting cost is at the rate of rupees 50 per square, let's say square feet. Okay. So let's say the length of this wall, out here is 15 feet, right? And the breadth out here is 10 feet, right? So what you're going to do first is, you will calculate the area. So the area is 10 into 15, which is 150 square feet. Once you have the entire area, you can calculate the cost of painting this entire wall, which would be how much? 1 square feet is costing you rupees 50. So 150 square feet is going to cost you, let's say, X. So you cross multiply and what do you get? 150 into 50, which is 0, 5 zeros are 0, 5 5s are 25, 7,500. So if you can judge the honesty of the painter now. So let's say you give the dimensions to the painter and then you ask him that, Bhaiya, how much will it be for painting this entire wall given these dimensions? And if he tells you that, you know, it is 8,000 or 9,000, then you can tell him, no, you're wrong. See, I have calculated the area, it is 150 square feet. At the rate of 50, rupees 50, it is going to be 7,500. So please give me a discount of 500 rupees and I'll give you 7,000 bucks and the deal is done. Right? So this is another example. Now property is also very expensive, especially if you stay in Mumbai. You must be having an idea. We have very tiny little houses. You will be very lucky if you're very lucky if you have a 3 BHK or something like that. Usually people are surviving in a 1-room kitchen. So usually when you go to buy, if you plan to buy a house in future, you will be given the cost as estimates as per square feet, right? So you can calculate the area of the house and then let's say the area of the house is 500 square feet and the cost of per square feet, so per square feet is rupees 5,000. This is very cheap, by the way. So how much would it be for 500 square feet? The total cost of the house is going to be 500 into 5,000, which is going to be 25 and 1 2 3 4 5 1 2 3 4 5, which is going to be 25 lakhs. So maybe you will be able to get a house in Virar with this cost, and if you want to renovate the house, you can add an additional 3 lakhs, or maybe a very grand house, let's say 5 lakhs. So the total cost with the additional expenses for renovation, it would be 30 lakhs. So this was about the introduction of why we are exactly studying areas, not in particular areas of parallelograms and triangles. We only covered areas, right? Let's take a look at the remaining topics in the subsequent videos. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.